Hello, everybody.
Oh, hi Alex. Good afternoon, everyone.
Hey, Adam. So as Adam may have posted in the chat, I guess we'll start formally in 1 minute, just to allow everybody else a chance to attend the lunch and learn. And ultimately, hope to have a sort of nice, informative, productive conversation with some insights, and hopefully, everyone attending can contribute to that conversation by way of any questions, thoughts, or observations. The conversation will largely, well, I guess largely is the operative word. The conversation will consist around large language models, which I'm sure everyone has at least heard of and had some experience with, I guess most notably from ChatGPT. Um, but before we get into that discussion, just allow me a couple of moments just to introduce myself. My name is Alex Kristich. I am a project manager at Beamdata. So we at Beam tackle a lot of data IT problems and projects that ultimately and increasingly have involved a fair amount of large language models, particularly the projects I think I've been working on. Um, it seems uh, it seems that every other project is in some ways a chatbot or a they call a retrieval augmented generating chatbot, which we'll get into momentarily. But given that, I wanted to have this discussion around large language models. And with that, I will share my screen and go through the slides. Um, as I say, every time I open up my screen, don't laugh at me or the number of tabs I have open. Um, Funnily enough, I know where everything is somewhat amazingly. Um, and yeah, feel free to just the tabs are relatable, I'm sure. I think I'm trying to set the record for most number of open tabs, certainly before my computer crashes. And I don't know how many there are. But what's worse is I have another browser window on top of this one with not quite as many, but it's my B screen. So if you think you have more tabs open than me, um, uh, that'd be incredible and sad, but incredible. Um, so and yeah, absolutely feel free to chime in throughout the course of this conversation with any chat messages, or feel free to unmute yourself and ask or contribute anything to the conversation. Um, so what are we going to look at aside from large language models, or more specifically within the context of large language models? Well, one, I just wanted to set up the sort of the context for this conversation and why we're having it. I think I alluded to it with respect to what I just said about the increasing number of projects I certainly am taking on and managing, and how great the demand is for large language models. And ultimately, from that context, we'll carry on a conversation about what that ultimately means. And what that could ultimately mean with respect to the projects that anyone looking at large language models will engage with, and what that will mean for you, the viewer or the attendee here, and how to maybe approach, adjust, and adapt accordingly. So takeaways for, oh, that's not the right slide. Okay. The takeaways for this conversation is just that, and I hope you in one sense, get a fresh perspective on sort of very typical large language model projects. And I hope you get sort of new ideas about how to implement large language model uh, project or large language models on projects that maybe don't readily come to mind in order to use. And then we will again take a look at sort of the benefits and the disadvantages of large language models and how you might want to adjust your course going forward. Because we'll ultimately take a look at what that means to you, this sort of proliferation of large language models. Um, that said, we'll go into the context. Again, as I alluded in the beginning, large language models are well, definitely here to stay. They're only increasing in popularity, and you've seen and experienced more likely than not the absolute explosion of large language models. I don't want to get too in depth into that, but ultimately, you're seeing it across well, just about every sector, from healthcare, finance, education, entertainment, and customer service, and that are asking for applications like chatbots, virtual assistants, content creation, and data analysis. Again, we'll get into the chatbots shortly. But just I found there's certainly a lot of statistics and ways in which to show like the demand and the proliferation of large language models. But ultimately, if we look at the brass tacks of it, you can see here the statistic on the slide that the global AI market, including large language models, is projected to grow from 93 billion in 2021 to $997 billion, essentially $1 trillion by 2028. And that's, again, an annual compound growth of 40.2%. So in some ways, I guess one of the takeaways here is it becomes, if you are going to work in this space, and if you are working in this space, then it becomes incumbent upon you to familiarize yourselves with large language models. And the degree to which you familiarize yourself with their use is, I guess, will be discussed in I guess, the last third of this presentation. But that said, this, again, proliferation of large language models has certainly left me with a problem because much has already been said about large language models, and much has already been written about large language models, detailing use cases and technical steps in which to sort of create things like chatbots and retrieval augmented chatbots. And I guess the problem here, and myself having done a prior presentation detailing one of the chatbots that we developed at Beamdata. So the problem for me then was to sort of like come up with something novel, maybe something that wasn't readily focused on, and maybe it should have been. And I hope to do that with large language models, and particularly the chatbots, because I do think there's a couple of things that are overlooked and seriously need to be considered in order to, one, develop those models, and then, of course, how you interact with those models. So just going to touch on chatbots and the best way in which to approach them. For those of you who are not familiar with, RAG chatbots, retrieval augmented generating chatbots, this is a case in which you have, I'll just touch on the slide here, but I think it's sort of better to discuss it. So when you have a large language model like a ChatGPT, and you ask it a question, its output is varied in general, in the sense that it can basically answer any question about anything, um, except your own particular set of data or documents. And here is enter retrieval augmented generating chatbots, because you may have a particular set of documents or data from which you want to derive answers from. And what we do here in this case is we take that source documents and we have to prepare it for the large language model such that it can retrieve this context, and then after retrieving it, generate an answer for the user. So in this case, we have a data source. The data source consists of whether it's PDFs, whether it's websites, whether it's CSVs, any sort of data source we'll take. And then what we have to do with that data then is then start splitting that up into little chunks, or smaller chunks rather. And when we split it up into smaller chunks, the aim of that is ultimately embedding those chunks of data such that they can get semantic expression in vector space. So essentially they become vectorized so that we can capture their meaning. Well, what happens to those chunks, to those vectors? They ultimately get stored in a vector database. And then when I have a user query, that query itself gets embedded. And from that point, we now look to our vector database to see the K number of similar documents or most similar documents to that initial query. So if I say K is 3, I have a user query. That user query gets embedded. And now we'll look for the 3 closest vectors in vector space to retrieve that information. Now, the large language model will also have a prompt informing the model of how it wishes to instruct that particular model in terms of outputting that response. So it will take the instructions from the prompt, utilizing the context that it's retrieved, ultimately generating an answer for the user that's again based solely, ideally anyway, solely on the source documents that you have provided. So again, use cases for this are like, what if you had HR policy, and rather than going through the typical procedures of, well, thumbing through a HR manual, you could just say, sorry, what is the policy by which to where can I sort of how can I schedule vacation time off, or is there a dress code, or what's the company's policy on this? And again, one of the great things about this is ideally it should stick to the source material and not wander off script, which large language models by themselves might have and do have a propensity to do that. And we call that a sort of hallucination. It sort of makes up things. And the idea here behind RAG is that if you have source documents, you instruct it to only derive the large language model's responses from that source documents and to sort of stay on script, then you would mitigate the problem of hallucinations. And for very sensitive use cases, perhaps like HR and certainly a whole bunch of other things, you definitely want to do that. That's just a really brief overview, high-level overview of RAG chatbots. And everybody, I always say, everybody has now sort of wanted or demanded a RAG chatbot. And again, this has been sort of the nature of a lot of my projects here at Beamdata, just developing chatbots for various companies, for various use cases, one of which I'll get into a little bit more specifically. And again, much has been said and written around the idea of how to actually create a RAG chatbot and what it does and all these things. But I think one of the things that hasn't been touched on, certainly hasn't been touched on enough, is the fact that it is still very much a business problem. So in having developed a number of these large language models for various clients, ultimately, I think the tendency and the temptation is to get sort of bogged down in the technical implementation. And of course, that is absolutely necessary and important. However, I think you have to phrase it or have a business view of it in order to inform the technical implementation of these RAG chatbots. So what do I mean by that? Well, typically, this is a chatbot is presented to the user when the user is engaging with your product. For instance, when you are scrolling Amazon, or sorry, looking to purchase something on Amazon or need customer assistance or any one of those customer service agent chatbots, you're engaging with their product. Maybe for the first time, or maybe this is, you're a typical customer user. But regardless of whether you're a customer user or not, you fall somewhere on the customer life cycle. And your engagement with this chatbot is an engagement with the company, with the product. And I think everybody would be mindful to be very aware of that and what that means. So again, at the end of the day, if somebody is engaging with your chatbot, with your company, you want them to walk away with the most easeful, engaging customer experience. So that again, if they're not a customer or client, they're a little bit closer to being one. And certainly if they are an existing customer or client, well, then let's keep them that way. So uh, so ultimately where this is sort of most prominent in terms of you're thinking about the business problem of RAG chatbots is in the prompt engineering. And as I mentioned earlier, the prompt engineering is your instructions to the large language model and how it generates a response and what kind of response and what does it provide. And you should be guided in that approach by ultimately realizing that your job, in addition to, of course, providing accurate answers, is to facilitate the best experience possible for that particular user. And to some extent, that goes beyond simply giving them the answer. So I think I can best illustrate that by way of a use case. So one of the chatbots we developed here at Beam was this personal finance chatbot for a major media publisher, and their readership had a significant interest, again, in personal finance. And the thought was that they could engage with this chatbot and ask any personal finance related questions insofar as an article had been written by them covering the area that they were looking into. So the thought was, yes, we definitely want to give them an answer. But we also had to think about a couple of things, and I sort of break it up into two categories, ultimately guided by the fact that you want to create the most engaging experience possible, particularly for this company, because I'll just show you sort of like detail how we went about doing that. But ultimately, we wanted to think about, okay, well, what happens when you have an answer? That the source documents contain an answer that can be retrieved and then given to the user. What happens when we don't have an answer? What do we do? Is it enough to say, sorry, we don't have an answer for that? That's sort of great. All right. I guess my interaction stops there. Maybe I ask another question, maybe I don't. But there's nothing that sort of moves the process of engagement further, sort of ends abruptly. Wouldn't want a user to leave with that sort of experience. It's not an optimal experience. And then, of course, what happens when we have an answer? What do we do? What do we instruct the large language model to do? Um, Particularly to facilitate greater levels of engagement. Well, in both cases, we used links to their site and links to their articles. And what I mean by that is when we had an answer and it was generated from the source documents or the articles from the client, we would certainly provide that answer. But more than that, we thought, well, it's great, but what if they wanted to read more? So we wanted to give them the links to those articles just in case they wanted to read more. Um, so that again, they can continue the process of engagement and they can continue their time on the platform. And um, the incidentally, the side benefit of that is that that company also has a recommender system so that it would recommend you articles that it thinks you might enjoy. Well, when you click onto the article, it sort of has downstream effects of going into your user personal history. It says, oh, John Doe interacted with this article. And then that goes into your personal history so they can make more informed, better choices about what articles John Doe is recommended in the future. So it's sort of like two birds with one stone. Uh, Actually, even within that section of whether we have an answer, we also wanted to distinguish between some of the questions that might arise and some of the responses that may need to come back as a result. So what I mean by that is I have a personal finance question. Um, what's happened to mortgage rates in the last year? Notice the time frame on that, the last year. So if I retrieved an article from my vector database, my source documentation that from 2018 about mortgage rates and what's happened, it really wouldn't be very it wouldn't be in anywhere in the realm of what I was looking for, right? I mean, that's all right. That's 6 years ago. That's not what I was asking. So to that extent, we had to identify time-sensitive questions. And time-sensitive questions that had to know today's date and then, how to retrieve documents from a given time frame that was inputted with the user query, so that ultimately I would get what I wanted, which is an article from the last year detailing some aspect of what has occurred with mortgage rates. Again, uh, ultimately leaving me a happier experience. All right. Ultimately giving me a more satisfying experience in which I come away with what I wanted and ultimately a better experience using the platform. There's also questions again, what do you do when you don't have the answer? And for that, we also leaned on links. So again, personal finance question could be, okay, well, what's Tesla stock at now? It's sort of like real-time information, and it's not necessarily the case that this chatbot, which would sort of just rely on a corpus or articles, would have up-to-the-minute information or articles on Tesla stock, because I'm sure you want to know what Tesla stock is worth now, not 2 months ago, not even last week, not even yesterday. So to that extent, we engineered the prompt to identify these sort of real-time questions. And again, rather than say, sorry, we don't have an answer for that, uh, and leave it at that, we wanted to sort of, again, provide a link to the client site where they would find real-time stock information. So that even though it wasn't a part of the vector database, we can still provide them with a path so that they could get their answers. Um, And by doing so, again, you sort of want to optimize the level of engagement. They're now still on the site. They're looking and interacting with the client's platform. So again, these are sort of like the micro details of a larger perspective, which encourages you to look at the business problem. And the business problem is ultimately, on a very broad level, facilitating that user through the customer life cycle in terms of, will your interactions with this chatbot and this company uh, make you more inclined to be a customer or client, or less inclined? If you are an existing customer, are you likely to stay one based on these interactions? So again, that is how I would and have and will continue to approach chatbots, and particularly how I approach the prompt engineering of chatbots. Um, so as I mentioned, again, chatbots, everybody wants one. It's fairly standard um, large language model project, and often asked for. There are other ways in which we can use large language models. One's probably not as readily thought of as, say, a chatbot. And one of which was a project we got to work on, oh, maybe 2 or 3 months ago, where we had to create a verification system for a transportation app. And I'm sure that if you've ever logged onto Instacart, Uber, um, Airbnb, you as a potential renter have had to undergo, hopefully anyway, a series of verification steps. Um, Maybe you had to be a certain age, maybe you had to have a certain accreditation, or ultimately there was a series of qualifications that you had to pass in order for the company certainly to feel at ease that you are a customer or a renter. And this app and this company worked in a similar manner. There was a problem though. So what would happen is, because it's a transportation app, we had to take a look at driver's license. And from the driver's license, we had to extract certain things, like your age, right? I mean, you had to be, in order to be a renter, you had to be 21 years or older. You had to have a valid driver's license. And we would have to extract this information from the driver's license, and then pass you through that set of qualifications. And to that extent, we could engage with um, things like TextRact from AWS, which essentially helps you extract text um, from images like a driver's license. And that's all well and good, but the problem that large language models solved for this particular project is, while this transportation app was sort of, at this stage anyway, more geographically based in actually in Ontario, like any company, it had eyes towards expanding, certainly outside of Ontario to Canada and to North America. However, if you have been outside Ontario or wherever you're from, I am from Ontario. Your driver's license and identification look a lot different from mine, and it is in a different format. So we have to parse all that. And especially sort of before large language models, we had to parse that. So for instance, if your date of birth, which we have to extract and recognize how old you are today, was month, day, year, like, 01 dash 01 dash 85, or 1985, that wouldn't necessarily be the format in, say, Alabama or California, Manitoba. And you then have to sort of account for the variations by which that information is presented across um, driver's licenses. So ultimately, we turned it over to the large language model to extract that information and then standardize the output so that we could take that output in whatever way it came, standardize it to say, no, look, we're gonna take however it's formed, we're gonna transfer that into O1 dash O1 dash 4-digit year, and then apply the qualification steps thereafter. Whereas previously, you just sort of be a headache about maybe you want to do like a regular expression, maybe you want to take some other library, but it was uh, a, a lot more involved than it was with the large language model. And for the large language model, in our case, all we sort of had to do was prompt it and specify the output of where it could find the information that we were looking for, and then what was the format and the structure that we wanted all that information to ultimately be outputted in. After that, everything was easy. Well, not easy, but easier to turn to the client and say, we are now positioning you in a way that you can be um, the code is robust enough so that you can expand to other provinces and other countries without having to go back and change some of the code to account for this format that we didn't anticipate, or that structure that is sort of novel to whatever area it was in. So that was, again, just one of the ways in which we, I guess, had a, I don't know, I wouldn't say novel, but a less thought of way in which to implement large language models. Okay, so having gone over large language models, I want to talk to you about just things to consider, and specifically around how large language models will inevitably impact you and the industry, but particularly you, because you will be working in the industry if you're not already. So one thing that's great about large language models is its enhanced productivity. If you've interacted with it, I'm sure you've experienced this troubleshooting, code writing, things that would normally take, just uh, a terribly long amount of time, are now sort of just solved in seconds, saving you, hours, if not days, on particular projects. So that's great. The other great thing about it, depending on who you ask, is the democratization of skills. So what do I mean by that? Well, a large language model is very smart, and prompted correctly, it can give you very smart responses and outputs over, as I mentioned, variety of topics and skill sets, so that you can probably interact with deep learning models or AWS or any of these things without as maybe as extensive a background as was previously thought you would need. And to that extent, people um, who don't specialize in these areas, AWS, deep learning models, or whatever it is that you're engaging with it, they have access to these answers too now. And to some extent, that's a great thing, because I guess it allows for a fresh perspective and sort of thinking that goes outside the box. But there are ultimately issues with both of uh, these benefits, and those are reliance and competition. I mean, amongst a few of the few disadvantages. Reliance, well, yeah, it's all too easy to generate an advanced output from a large language model like ChatGPT, to the extent that I think there was I can't remember when, maybe you guys do, OpenAI went down for, I don't know, it was like 4 or 5 hours or something to that effect, a couple like 4 or 5 months ago, and to that extent the tech industry just stopped. Like, so being that reliant on large language models for the output for your work is ultimately problematic. But the other thing is that I mentioned the democratization and more people now having accessibility to enter the tech space, which creates, I guess, a greater level of competition. And that's certainly true. But in addition to competing with other people, you're actually, in some sense, or at least I feel anyway, that you're competing against the large language model. Um, because, well, if it's that easeful and you can generate advanced outputs that previously only um, seasoned professionals and specialists could, then I mean, why would I give you the job? Um, why wouldn't uh, it sort of just phase you out of the picture and like, okay, well, we'll let it do its thing. And certainly depending on the level of advancement it reaches, maybe that will increasingly be the case. But I posit that because I think it's beneficial for us certainly right now to think of large language models certainly as an assistant, but as our competition, because that should inform our approach. And this is what I mean by that. Ultimately, because it's so advanced, we don't need a degree of specialization that we once had in, say, Python, in, say, in data engineering. And don't get me wrong, the specialist is I think always welcome, and there are still going to be specialists, but short of being a specialist, I think it becomes incumbent on the person working in tech to become a generalist. Uh, and what I mean by that is, if you just take data science, for instance, you can specialize in data science and you can generalize in data science, right? Like if you're, taking up, I don't know, um, fraud detection or something like that, or no, computer vision, better yet. You can be a specialist in computer vision. And the generalist will have some idea of how all these things work, whether it's through recommender systems, whether it's through uh, forecasting, any type of like sort of traditional machine learning. But I'm actually talking about a level of generalism that exceeds that level of generalism. Um, because again, it's so good. It can do so many functions uh, and extend beyond areas like data science to data engineering to machine learning engineering to sort of front end, back end development, that you now, as a practitioner in the data space, if you were in data science, for instance, sort of generalizing, you'll have to sort of generalize a little more because I think companies will rightfully understand and appreciate just how powerful this large language model is. And they will, why would I hire one generalist for data science and one generalist for data engineering when I can hire the one person who has a general understanding of both of those fields, such that, um, whatever knowledge they need to make up is done by the large language model. So I'll I'll sort of just put that out there, and you can think about that. But and it's certainly just my opinion, but again, the degree to which you have to be a generalist will, I think, ultimately expand if you are to be um, viable and have a degree of longevity in this field. But the other thing I think you will need moving forward is is a is a great deal of creativity. And maybe creativity is not the best word, but it's the word that I use when I guess when I'm instructing the the consultants on working on this project. Um, and what I mean by that is you have to, and I think it's closely tied with the second bullet point there, initiative. You have to distinguish yourself from the large language model. Because if I ask you to do something and say it's like, oh, I don't know, just make the calculations for whatever cosine similarity exists for this embedding as opposed to all the other embeddings and see what the closest is, or something to that effect. And you do that, and then you sort of present it and go, oh, here it is. And I go, okay, is, is that all you got? Because I could have done that. How are you distinguishing yourself from me or anybody else who just sort of typed in a prompt and got the answer? What further investigation did you do? What what analysis did you provide? What additional thing based on that output did you look into to inform your approach going forward? I think that's what you'll have to do, because otherwise it's like, if it can be done through if it was just a matter of completing the task as is, then I think you're going to be out of luck, because, well, why do we need to pay you that when I could just be at the keyboard doing that? Um, And that's what I mean by having to distinguish yourself with some degree of initiative and creativity. Uh, Again, separating yourself from the competition of people and the large language model yourself. And I think ultimately, too, the person who can strengthen their communication skills will ultimately reap and yield better results in their projects from the large language models and in their career in general. I think now more than ever. And what I mean by communication is the use of language to articulate concepts and instructions moving forward, because uh, ultimately, the large language model is going to be as, I guess, to some extent, as good as you instruct it. And it's only going to be as good as you instruct it if it understands what you're saying on a very specific level. And I would say that I always emphasize this because I'm never surprised, but always shocked at the level, at the degree to which the communication skills are underappreciated, underdeveloped in this industry. And it's in some ways it's certainly understandable, because if you're working in data, you're largely at your screen interacting with that and coding, and more often than not, you're communicating in a style and a type of language that I guess is uh, very technical. Or when I communicate something to somebody who's sort of in the same space, we don't necessarily have to make all the we don't have to elaborate or clarify, although we should, on certain matters, because maybe we get it. Like we have a sort of a base level of understanding where we don't really have to get into the weeds about specificity and clarity and, no, no, what did you mean by this? And how does that affect that? So ultimately, I think, given how well it codes, how well it does everything, um, the person that can clearly articulate concepts, instructions, and specificity is going to do better, and will thrive with that. Because again, it's just simply not a matter of typing in whatever statement and having an excellent result. An excellent input will create an excellent result. So ultimately, those are uh, my thoughts anyway on what you, me, we uh, will need going forward to future-proof our careers in data to some extent. But that's just what I think. I am interested in what everybody else thinks. So please feel free to ask any questions, chime in with your thoughts, um, and we can, I guess, finish out the last 9 minutes of our conversation with hopefully some insights, some additions. Is there any questions? There's no questions.
Yeah.
I will again, I always say this because I think it's sort of incredible to understand, to actually just conceptualize. Um, so I think the difference between GPT-3 and GPT-4, um, GPT-3 was, I think, sort of measured at an 80 IQ, and 4 was 160, which is the level of Einstein. And it was sort of projected based on, current trends, um, at that rate, to grow its intelligence by 10x, so that it would ultimately have an IQ of 1600. Now, if you take Einstein in the 1970s and have him explain his theory of relativity to, let's just say, the person with the lowest IQ in that society, it would go over their heads. Couldn't understand it. What are you talking about? Um, if the large language models develop their intelligence by 10x and we have an IQ of 1600, and we provide the output looking for an explanation, uh, will we be that person in the 1970s whose explanation of Einstein's theories just went over their head? Who knows? And the last thing I always like to sort of think about, and hopefully I give you this to think about as well. Much has been said. predicted about large language models, maybe how they'll replace us, the jobs that they'll take or whatever. But I think an interesting thing to think about is the degree to which we will have in ourselves uh, some sort of existential crisis as a species, given that prior to this, it was us who we were the the preeminent thinking entity in the world that drove innovation, that drove invention. We were at the forefront of that. And now, for the first time ever, we will and are taking a back seat to that. And as such, um, relegating us to at least secondary role in that innovation. Something to think about. Anyway, that concludes, I guess, the lunch and learn. I hope you did learn something. I hope it was a valuable conversation. Adam, did you have anything you wanted to add?
No, I think thank you for joining this session. I know we have small group of audience, and yes, I think this session be live on the different platform. Any of audience are interested to learn more about Wake data, I can go to our website, and we will have this events like constantly going for like every week, and you can join the meetup and YouTube to follow us. Thanks again for Alex and to give us very detailed introduction to the Beam data. And yeah, so if more audience interest, we can host this session like sooner. But normally we will have this session like once a week by the different project manager and share different informations. Yeah.
Oh, hope to see everyone again.
In here.
Thanks so much, everyone. Bye.
Thank you, Alex. Bye.